quick video on surds. Well, we've been introduced to them through quadratic equations. If we try and solve that quadratic equation there, or we come out with solutions to roots that have got a rational integer element there, but it's a rational part, that's the most important thing, and an irrational root part as well. And that led people to have to work out how all the maths works and look at a lot of the common misconceptions with this, because people start mucking about with the rules. And so let's just go through all the operations and how they work. Okay, well, the first one is we're going to have to be able to add and subtract surds. So if we have a look at the first one here, which is straightforward addition, we've got the most important thing we're going to deal with is collecting up terms and carrying out operations. So the first one here is about collecting up terms. So we've got a 1 here. I'm just going to change colour. Got a rational 1 there, and we've got a rational 2 there. So we can add those because they're rationals. Yep. So we've got 1 plus 2. And we've got irrational root 2 and irrational root 2 there. So we want to put their like terms so we can add those together. So I've got 1 root 2 here, and I've got 4 root 2s here. So that's it. So that's ultimately I've got 5 root 2s, haven't I? So I get 3 plus 5 root 2. Same thing happens with subtraction. We're collecting and using the operations here. So it's 5 minus 2 gives us 3. Yep. Ditto. 3 root 2 minus 7 root 2 will give us minus 4 lots of root 2. Just want to point out that if the irrational part was a root 2 there and a root 3 there, we can't just add them together and go, oh, that's a root 5 underneath. No, it isn't. It's we can collect up our rational parts, our 3 and a 5, to get an 8. Then we've just got a root 2. That's like its own sort of type, a bit like an x squared or an x cubed. It's a different type of, it's a different number. And then we've got 4 lots of root 3, so we have to write them out in that way. And the same thing happens if we do taking away, subtraction. Remember, root 2s are different to root 3s, are different to root 5s. Yeah, and we have to collect them up separately. Okay, let's have a look at multiplication. Well, what we've got here is 2 parts, just like in a bracket. Or just like in a 10 and a 1, and we've got to think about splitting them up if we're doing multiplication. So I'd recommend you stick with your normal way of doing it, either grid or smiley face, whichever you like. But in this case, I think grid makes it really clear. So here I've got a 1 plus root 2 here, so I put those in the different boxes, and I've got a 2 root 3 there, and I'm multiplying them together. So I get 1 times 2 is 2. I get 1 times root 3 is root 3 over 2. Then I've got a root 2 here. Excuse me. A root 2. Root 2 times 2 is 2 root 2. And a root 2 times 3 root 2 is going to give us 6. Let's just check that out, and we're happy with that. That's 3 times root 2 times root 2. Well, root 2 times root 2 is 2. Yeah, we're happy enough with that. So we've got 3 times 2 is 6. Yeah. So if we're collecting our terms here, we end up in the rational part. We've got our 2 and our 6 to collect up. That's those 2 there. And then we've got a 3 root 2 and a 2 root 2 there. So we've got 3 and 2 is 5. So there we go. Again, just watch out. Second variant here is, so I've got a root 3, a root 2 there, and a root 3 here. Then we're just going through the same grid method. We end up with 3 times 1 here, 3 times 15 root 3, so that's our 3 times 5, 15 root 3. A root 2 times 1 is root 2, and a root 2 times 5 root 3. We've got a 2 5s on the outside of the rational part, and then we've got a root 2 times a root 3. Now they're both roots, so we can take, they can stay in the root, can't they? Inside they must stay in the root, and then we can multiply them together, and there we've got root 2 times root of 2 times 3, and that's going to give us a root 6, isn't it? That's a root 6, and we got our 5 out the front, so that gives us our 5 root 6 on the end. Yeah, so here we've got, ultimately we end up with 3 different irrational parts here. We've got a root 2 part, we've got a root 3 part, and we've got a root 6 part. Going on just to look at multiplying roots on their own, well, I think we'd be happy, wouldn't we, that root 2 times root 2 is 2. There's two ways of looking at that. That's either the square of root 2, so that would be 2, or we can think about it, which I'd recommend starting to think about, is we've got two values within the root. So I've got 2 times 2 there, which is 4, and the square root of 4 is 2. So that gets us there. Because the reason I'm interested in this is if I've got a root 2 times a root 3, what I can do is they're both rooted, so they stay inside the root symbol, they remain as roots, and which says we're going to multiply them together, so we can multiply them together. So we get 2 times 3 is root 6, yeah? Okay, the reason I'm suggesting this way of looking at it is what happens if we get 2 times root 2 times root 6. Well, they're both roots, so they can be multiplied together inside the root function. So that's 2 times 6, and we could just write that as 12, couldn't we, as root 12, and leave it at that. But actually, if we have a quick look and we factorize this, we can see it's a 2 times 2 times 3. And because, again, all multiplication is commutative and distributive, we can split this into two separate calculations here, and therefore we can have root 2 times 2 in this bracket and root 3 over here on its own. And again, we can see that 2 times 2 is 4, and the root of 4 and the root of 4 is 2. But generally, we can see that we've got squares of the roots there, haven't we? Which brings us back to 2. So we've managed to move those part of this outside the root, haven't we? So we've got our root 3 left here, and the front part we've now got a rational value of 2. So we end up with 2 root 3. So by looking at doing multiplications within the root function, inside the bracket in effect, and then breaking it up into its factors, looking for any squares that we've got in the factors and taking them back outside using sort of maths we've just done there, we can break up some quite complicated surds. Okay, division's the odd one out. It's got quite a lot of new thinking in, because if I had this expression here, 2 plus root 3 divided by 1 plus root 2. Yeah, remember, division is the same as fractions in this respect. That looks pretty horrible. It doesn't look like we can do much with that. But actually, by convention, we always have the irrational part on the top. We want to get rid of this on the bottom, and it's always possible to do it using a piece of maths that we've looked at in the past, which is called using a conjugate. So if I've got a value here, 1 plus a root 2, then the conjugate is 1 minus a root 2. And we can remember, I'll just move that up a sec, from our general equality that we've looked at in the past is that any a plus b times a minus b equals a squared minus b squared. Let's just draw that out. That's going to be a plus b there, and that's an a minus b. So on the grid method, a times a is a squared, a times minus b is minus ab, b times a is ab, and b times minus b is minus b squared, and these two cancel out. Yep, so there's a squared minus b squared. And if we had a look up here at the one above, remember we got a 1 plus root 2 there and a 1 minus root 2 here. Then we've got 1 times 1 there. We've got a minus root 2 here. We've got a plus root 2 here. Yeah, root 2 times 1. And here we've got a minus 2. So here we can see again that these two cancel out, and that just leaves us with the 1 and the minus 2. Yep, so that would give us 1 minus 2 is minus, so that will become minus 1, won't it? We multiply those two together. Okay, so how can we use that to simplify our example here? We've got some surd on the top and we got this surd on the bottom. So what do we want to do to make that a rational number? We want to multiply it by the conjugate 1 minus root 2, and if we multiply that on the bottom to keep the equation still equal, I have to multiply it on the top, don't I? Because if I multiply it top and bottom, then I could cancel those two out, couldn't I? Because a number over a number is always 1. Yeah. Okay, and then so I can introduce this term here onto the end, which equals 1, doesn't it? Okay, then I can do the multiplication because of commutativity, etc. that I get in distributivity. I can go and multiply those two first and those two first. Yeah, I brought them in on the basis that I could do that divided by that first. Okay, if I multiply at the bottom, we've already worked that out above, didn't we? That was going to become 1 minus 2. Now I multiply out on the top, again using the grid method. So I've got 2 and I've got 3 root 2 and I've got 1 and minus root 2 here. So in the first box I'm going to have a 2, sorry. In this box I'm going to have a minus 2 root 2. In this box I'm going to have a plus 3 root 2. And in that box I'm going to have a minus 3 root 2 times root 2, which is going to be 3 times 2, isn't it? Which is minus 6, yeah? So what have I got in my rational part here? I've got a 2 minus 6, and in my irrational part I've got a plus 3 minus 2, lots of root 2. Yeah. So that equals 1, that equals minus 4, doesn't it? So I've got a minus 4 plus our root 2 here, all divided by minus 1, which therefore is just divided by minus 1 gives us 4 and minus root 2. So actually we've shown that 2 plus 3 over root 2 divided by 1 plus root 2 is the same as, it's equal to 4 minus root 2. Now I don't think that's an obvious result, but it's worth spending time to satisfy yourself that you know what you're doing. Okay, I want to have a quick go through some misconceptions. If I've got this bracket in multiplication, I've got this bracket multiplied by that bracket. Don't just multiply these two and those two. We know from the grid method that we have to go through and multiply both sides. So that's wrong. Yeah, that's the same as if I replaced here these numbers with a 3. Well, where the root 2's are, I'd have 2 plus 3 is 4 times 5 times 4 is 20, isn't it? If I did that, I know that's 20. That's like only multiplying those two and those two, isn't it? And saying, oh, it's 2 plus 3 is 9 is 11. It's not. Yeah, make sure you do your grid method in these ones and make sure you've done all your calculations. Division's the one that seems to, and fractions seem to be the one that completely throw people. Sometimes you see people and they go, oh, I've got a 2 plus root 2 here and a 1 plus root 2 here, so I can just take off my root 2 minus root 2 from top and bottom. So I just end up with 2 over 1. Well, if that was true, using the same thing here, if I replace the root 2 with a 3, then I could just get 2 plus 3 would be minus 3 here, and 1 plus 3 would be minus 3 there. So that would be 2 over 1. But it isn't. We know it's 5 over 4, don't we? Other things you see people do, they have a look here and they say there's a root 2 here and a root 2 here. So effectively I can cancel these in terms of like a division method, that root 2 over root 2 is 1, so I can put a 1 in its place. And therefore it's 2 plus 1 and 1 plus 1. Well, that's the same again if we could just replace, if we had a 3 in that place, that we could just replace that with a 1 and a 1. None of that works, does it? That's not how addition and division work. You've got to be looking at doing it by, we'll come on to that in a sec, but we've got to be doing it by factors. Finally, you see people who try and split these up. So here I've got 2 plus root 2 and 1 plus root 2. So they just go, oh, I'll just deal with the rational part 2 over 1 separately from the irrational part 2 over root 2 over root 2. And I get 3 again. Yeah, that's the same as we said here, 2 plus 3, 1 plus 3 over here. That's the same as splitting that in half. Well, it isn't, because that's 5 over 4 again, isn't it? We can't split it down there and get 2 over 1 and 3 over 3 and turn it into 3. Always what we're really doing here is factorising, and factorising is all about multiplication, isn't it? Multiplying. Yeah. So in this case, on the top, I've got 2 plus 2 root 2. I can see that 2 is a factor there. I can take the factor outside. If I do that, I'm now left with 1 plus root 2 on the top and 1 plus root 2 on the bottom. And therefore I can cancel them because these are multiplications on the top and divisions. Yeah, and therefore any number divided by itself is always going to be equal to 1. Yeah. Okay. Here's a quick summary of all those points. I've just written out a version of each one for you to copy down. Right, I hope that's of use.